Yes, I do.
Switch to my watch. I do because
Oh, no. Look, Mrs. Scott. Y'all doing be difficult. Stop calling me. Right here?
It's a four.
Let me grab my phone down.
so are you teaching them?
Go five. It was a 3 right now. I thought it was a 4.
Whatever. I ain't around.
So take the knife.
Don't take no knife.
I said if I did, if tonight we cut the edges, how it was just ours.
Okay, you cut that good. Could you want to cut no, could you want to break it, please?
So for number 3, she got 18,623. Agree, disagree?
Agree. Yes, agree.
And then number 4.
I disagree.
Where did she go wrong?
I'll just put on mine and cut it.
DeAndre Goldway, correct. Number 4.
No, what? I know he's gonna work there. He's gonna play right.
You want it?
Yes, of course.
You get it from? Wait.
No, yeah, he would get.
Yep.
I didn't raise
What was her mistake? Her mistake was she didn't raise. Listen up. Her mistake was she didn't raise it to the 6th power. She didn't multiply by 6, which would throw off your answer. So if DeAndre would correct it, it would be 2,139. So make sure you have it on your paper. Put that to the side and take out another sheet of paper for your notes for the day.
We can't write on the bottom of there?
Nah. Class work the same sheet. Except everything.
Y'all are so slow. First period, I put 2012.
So for these set of problems here, we were trying to find the future value. We were trying to find the principal, given the compound interest and also given the time. Today, like we did last week, and I know I wasn't here Thursday to reinforce it, we're going to find the time again using the logarithm to figure it out. Oh, we'll come back to that 18 prep in a minute.
Do this on good half back.
No, take notes on the 7 sheet of paper. So last week I told you the very long, extended version of how to solve for t. And this week we're going to shorten it up a little bit. So we're going to do number 1 as an example. You have a 3-year investment of $20,000 that receives 7.8 interest, compounded semi-annually. What is your balance after 3 years? We'll skip that question. The question I want to focus on is how long will it take for your investment to double? So there's a few things I want you to point out or take out when you're solving this word problem. So your first one is to label everything like we did previously. So what is our rate?
Right?
In decimal form.
0.078.
And our time, well, our time is going to be irrelevant because we're trying to figure out t. So our t is unknown, right? What's the present value?
20,000.
20,000.
And my future value, what am I trying to do?
Double it.
Double it. So the 20,000 double is what?
40,000.
And then last but not least, how many times?
7.8%. Oh, yeah, I got that. 3 years.
I'm asking for the
Is
end.
that what you asking for?
What you asking for?
And how many times is it compounded in a year?
Oh,
2. Yeah, 2.
one.
It's 2.
Oh, I'm sure.
Two.
Two.
Two, so it's semi-end. So we're solving this, we have an unknown of t. Last week I showed you the long way of dividing everything and canceling and all that other stuff, and it took you a while. It took half a sheet of paper. This week, the shortened version is take log of your future value divided by your present value,
What's it?
Future value.
divided by log of 1 plus r over n.
What happened now?
Do it however you understand. It was the old way. So the future value would be PO, and present value would be P. Okay? Yes, ma'am. That is a division sign, so it's FB divided by P. And then once we get a final answer or outcome from this, we'll just go ahead and divide it by n again, and that would tell us our unknown variable of t. You said y is log right there, room? You missed last week, didn't you? Again, our standard is recognizing and exploring logarithmic functions as inverses of exponential functions. So what it's saying is logarithms are just the opposite of exponential functions. So if I gave you 2x, I think I used this example last week, 2x equals 6, what would you do to both sides to solve for x? Divide by 2. And why would you do that?
Because you want to get x on side by itself.
You want to get x on one side by itself, and you're just doing the inverse operation of multiplication, which is what?
Yeah.
Division. So if we take this same problem for number 1, and we're trying to figure out how long it takes to get t. So we'll just plug this into this formula right here. So our future value was what, 40,000?
Yeah.
And our present value was 20,000. So somebody in their calculator, real quick, tell me what 0.078 divided by 2 plus 1 is. Somebody on the calculator? Q.
Yes,
0.078 divided by 2 plus 1.
okay. 0.0 what?
0.078 divided by 2 plus 1.
1.039?
Say 1.039.
Yeah.
So, Monique, to answer your question, why are we using the log, and what does that mean? Well, in order to solve this, we have an unknown the exponent, right?
This is 0.75.
That's 8. So we have an unknown in the exponent, right? And again, the standard is trying to get or recognize that log functions are the opposite of the inverse of exponential functions. So if we cover up this half, we cover our 40,000, 20,000 looks like 20,000 times 1.039 raised to the 2t. It looks like an exponential function, right? And because it's an exponential function, we have to do the opposite of the exponent, which is a logarithm, to solve for our t. So last week, this is the long way that we did it. So we have to take the log. Well, first we have to divide by 20,000 on both sides. I got your question in a minute.